Okay, so another video on Maths Specimen Paper 1. I thought I'd get the last 5 questions of the short questions done. Remember, these specimen papers are slightly easier really than the real thing. I mean, this would not be out of place on an old AS C2 paper. In fact, they'd normally just ask you to solve it. So without further ado, let's solve it. It's obvious here, replace cos squared with 1 minus sine squared, plus 5 sine x. And this is obviously a trigonometric quadratic. So what are we going to have? Let's put 0 here. We'll have 2s squared, or 2 sine squared x, minus 5 sine x, and then we take 2 away from the 4, and we get positive 2, and we factorise. I suppose maybe they're just checking that you know your exact trig values here. Yeah, no calculator, remember people, no calculator. If I put a minus 2 there and a minus 1 there, I think that works. So sine x is a half, or sine x equals 2, but that never happens for any value of x, and so x equals pi over 6, or 5 pi over 6, in that range. So the answer is 2 solutions, I think. Yeah, cool. Okay, next one. Also too easy for a G on these kind of questions. The real ones from 2007 onwards are a little bit tougher than this, but still these are, you know, these are great to start with, therefore, you know what I mean? Start on the easier ones, build up to the tougher ones. It's never bad advice in life. Okay, we've got to find where the inequalities are both satisfied. Well, this first one's fine if we just factorise it. They're quadratic inequalities, and students often get them wrong. Think about the graph. It's going through minus 2 and minus 1. We want it to be bigger than 0. And so that's going to be the case when x is less than minus 2, or when x is greater than minus 1. And now that's a really crucial, very important, critical word there. And or are very, very different. I mean this in the same sense that you meet it in stats when you start doing the Venn diagrams and the Boolean algebra. You know, they are very different words, and or make sure you can distinguish between the two. Now, let's take this one and just solve it normally first. X squared plus x minus 2 is less than 0. And so, what is that? X plus 2x minus 1 is less than 0. Now, we want this to be underneath between minus 2 and positive 1. And so, the solution to that is minus 2 is less than x, which is less than less than positive 1. So, minus 1 there, positive 1. Now, if you combine these two, if you said to me, okay, you've got to be less than minus 2 or bigger than minus 1, oh, and between minus 2 and positive 1, I think that the only way you can combine those, and with them both being true, is if you restrict x to lying between minus 1 and 1. Is that one of the answers? Yeah, it's B. So yeah, the answer is B, minus 1 to 1. So yeah, watch out for those. They're pretty typical once again in the A level. They do come up. They're not particularly easy. I always look at those when they come up and think, you know, like, that's only going to be done correctly by my top 20% in the class, I reckon, 10%, 20%, hopefully more than that. Maybe I'm massively underestimating. Underestimating? Isn't that what George Bush said? Okay, anyway, let's carry on. I think the answer to that one is B. Okay, this one. I've got a vague memory. I'm familiar with this paper because I started doing the specimens first myself when I first started doing that, and it worked quite well to lure me in, thinking, the math seems nicer than the step, because I'd seen the step first before I'd seen the math. Then I started doing the real ones, and I realised they're not all like this. But this was the first question I'd come to where I thought, ooh, yeah, how would I do this? So I guess firstly I'm going to look at this and think, well, let's just times that by 100 first, that one. Now I'll explain why I'm doing that. It's because it's something to do with 2 to the power of 100, and I can get a 2 to the power of 100 out of this if I do that. Can you see what I mean? Because 100 is going to move using log rules up, so it's power of 2. So from that first one I can deduce that, and I can therefore deduce that, sorry, that's supposed to be a log, log base 10 of 2 to the power of 100 is 30.1, and so I can therefore deduce that 2 to the power of 100, now we're getting somewhere, is 10 to the power of 30.10. Yeah? Okay, that's interesting. So I can see straight away that 2 to the power of 100 seems to be beginning with probably a 1 and is 30 digits long. That looks appropriate. Now let's have a look at this, because we've got to use this sentence somewhere. But I'm thinking like you know, it's A or C now. Really, I'm thinking. Pretty sure of that. But let's just try and use this. Now, if 10 to the 0.2 is less than 2, then let's just write this as 10 to the 30 times by 10 to the 0.1, because we would add those powers. Great. Now if 10 to the 0.2 is less than 2, then 10 to the 0.1 is definitely less than 2. Yeah, because that will be a smaller value than 10 to the power of 0.2, because, you know, 3 to the power of x is going to be you know, increasing. You know, 10 to the power of x is going to be a strictly increasing function. And so what can we now deduce? Okay, so we know that 2 to the power of 100 is, okay, this is a number which is less than 2 times by 10 to the power of 30, yeah? Which means it must start with a 1, because this is less than 2, so it's still going to be, you know, let's say this was like a 1.9. We'll be doing 10 times 10 times 10 times 10, like 30 times, and then times it by 1.9, which means it will start with a 1, yeah? Now, we've got it also, we've times by 10 30 times, and therefore it's going to be 31 digits long, because the 1's going to count, it's going to have 30 zeros after it. So yeah, not easy, that one, not easy. I thought that was quite, you know, quite subtle. You know, just to make that last point, 10 squared is 100. That's 3 digits long. 2 of them are zeros, and the leading digit is a 1. So yeah, that's why it begins with a 1 and it's 31 digits long. That's how I did that one. Yeah, not that easy. Okay, what's this one? I. The power of x which has the greatest coefficient in the expansion of 1 plus a half x to the 10 is that. Right, this is ironic, because that was entirely what the question, where's the step question I did this morning? It was entirely about greatest values in, this is so ironic, in binomial expansions. It really was. It was exactly about that. We had a little formula for it to find the greatest value in a binomial expansion where these were integers, but it would be trivial to turn this problem into one where I could use that formula. But you're not going to probably think about doing that, but I just found that quite ironic. When I scanned down it, I thought, oh, I think I've got a trick for that, but I can't really use that trick. I shouldn't. Let's just do it the way we're likely to do it. So I suppose you'd probably just think about the x squared, the x cubed, the x to the 5 and the x to the 10, because it's not that hard to do. Okay, so for the x squared we'd have a 10 choose 2 multiplied by 1 to the power of, you know, 2 if you like, or 8 if you like, and then x over 2 to the power of 8. And I can ignore the 1 to the power of 2 for, 1 to the power of 8 for obvious reasons. Let's put this to the power of 2 because I'm trying to find the x squared coefficient. Okay, 10 choose 2 is like, you can work these out really quickly, remember, because it's just 10 factorial over 8 factorial, 2 factorial, and that's just 9 times 10 divided by 2, which is 45. So we've got 45 over 4 x squared there, yeah? And then we can just kind of work through this and do the same thing for all the other ones. This is going to be 10 choose 3 multiplied by x over 2 cubed. Well, it's just a 10 choose 3. That's 10 times 9 times 8 over 3 times 2. Can you see why? I've just basically cancelled the 7 factorial with that down there, yeah? Now don't faff about doing these, you know, make that a 3, make that a 4. So that's 120. It's not that difficult to do. You want to get slick with that. So that's 120 over 8 x cubed, which is like 15, isn't it? 15 times 8 is 120. Okay, so that one's winning if you like so far. What about x to the 5? 10 factorial over 5 factorial, 5 factorial. That's 10 times 9 times 8 times 7 times 6 over 5 times 4 times 3 times 2 times 1. You know, we have to do these quickly because we get rushed in these questions, don't we? 3 and 2 is 6. What else can we cancel out? 10 and 5 is 2. 2 and what can we do next? 8 and 4 is 2. I'm trying to cancel the ones on the bottom, which I have now. So I've got 18 times 7. What is 18 times 7? I think it is, what is that? 70 plus 56, 120. 126, yeah? So you've got 126 there. Now, don't forget what we're really doing here. I just got straight into the 10 choose 5 bit. We've got to put 126 times by x over 2 to the power of 5, and that's going to leave 126 over 32. And if we divide the top and bottom by 2, we're going to get 63 over 16. And then, I think I might have messed this up, you know, because I've got a different answer here. 2 cubed times 3 times 7, 8 times by 21. Did I mess up this here? I might have messed up this here. Let's have a look. Let's try again. 10 factorial over 5 factorial, 5 factorial, that's true. 10 times 9 times 8 times 7 times 6. Sometimes just my messiness is where it goes wrong. Right, cross that out, or maybe it's wrong when I've done it here. Put a 2 on top, put a 2 on top. Okay, 4 times by 9 times by 7. And 4 times by 9 times by 7 is 36 times 7. Which is different. I think I've done it right now. Leave a little comment if I've messed it up. Yeah, so what is that? 36 times 7, 210 plus 42, 252. And so that is 252, which is double that. And therefore, what have we got here? We can divide top and bottom by 2 twice. In other words, divide it by 4, I think. Or we can divide it by 8, can we? 8 into 252. A little bit of arithmetic. Right. Okay. I'm just wondering why I'm getting a different answer again. Just have a look at what I've done here. It might be that I've made a mistake here. I've got 4 times 7 times 6. I've got 4 times 7 times 4 times 7 times 9. Did I not cancel out 9? How did I get rid of 9? Apologies for this. A little bit of faff around. 9 and 3 makes 3. I think I've done something wrong on my page, and I think this is right. So 252 over 32. We would have ended up with the right answer either way, because I think this one ends up being not as large, and so the answer is B. But you can see at this point anyway that you're not going to, get very far with this. What is that? 126 over 16. Let's have a bit of confidence in my ability, and not what I've got written down on this sheet for ages ago, which is 63 over 8, but it's still not beating 15. Now, as I pointed out in the last video, it's now going to get smaller and smaller and smaller. You're not going to have a very big one there because, obviously you've got 10 choose 10 coefficient, which is 1, and so that's going to be very small. And so the answer is B, yeah? And apologies for that, and if anybody wants to comment on tell me that's wrong, please do. If it is wrong, could you just quickly check my maths there? It's probably the page I'm looking at, because this is notes I made years ago on these questions, and they're just rough notes, and yeah, there's probably mistakes in there. There's definitely mistakes in there. That's interesting though. Yeah, because I just did it with prime powers, but I don't know what I've done with that 9 there. I think I've cancelled it when I shouldn't have cancelled it. Okay, so anyway, this one, graph sketching. I love graph sketching. It's nice. If you get good at it, there's a really good feeling for it. I mean, first thing I'm thinking of is both A and B, no chance, yeah? Now, why is that? Well, it's because when x is 0, y is 1. That's what that's saying to me there, yeah? If you've got x's or y is some value it can take. But when x is 0 here, you get 0 times by y equals 1, which is a contradiction, which is exactly why the y-axis, where x is 0, is going to be an asymptote. It must be C, yeah? And it's the same with, if you take the same logic on the other side. This is called a symmetric function, by the way. If you swap the x and y's around, you've got exactly the same curve. It's a symmetric function. It's symmetric in y equals x. It's self-inverse, yeah? And yeah, so this is going to have the same problem, like down either here or here or here, yeah? When x is 1 and y is 0, when you take y as 0, you've got no solutions to this. In other words, y is 0 is undefined on that curve, and therefore it has to have an asymptote on the x-axis. So it must be part C. That's the easiest question a lot for me. It really is. I don't have to do any terrible arithmetic like I had to do here. Let me check that again. 10 over 5 is 2. The 3 and the 2 I cancelled with 6. The 8 I cancelled with 4 and left a 2 on top. And so I've got 4 times 7 times 9. Yeah, that's right now. It's wrong in my notes. I'll quickly adjust that. Okay, hope you enjoyed the video. Hope you enjoyed me making a mistake as well. or suddenly having a moment. Yeah, best of luck with the mat or the step if you take it.